This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Mr. Jerzy Nowiński, can we welcome him to the stage, everybody? Give him a hand. And the topic is how to build real-time video processing web app by ShareTheBoard. One more time, welcome Jerzy to the stage.
Yeah. Hi, hope you can hear me. You can hear me well? Great. Okay, so hello. Let me present you some information about how you may approach creation, development of video processing web application. It will be based on our experience that we have while developing ShareTheBoard. So first, who am I? I'm a head of development in the company, and in the past I've been working as an engineering manager, development manager in various areas like telco, data governance, big data, and finally video processing and machine learning. But what is more important is ShareTheBoard. And this is the application, web application, that is used to detect and digitize handwritten content in real time. I guess it may be interesting for you as we are using a lot of various machine learning algorithms. We use various classical computer vision algorithms. We use a lot of cool tech, which is quite new. And as well, the project itself, it's, I would say, research and development project, because what we do often, like we need to go beyond what is currently possible and test the new ways of how you may approach stuff. And to say it's not yet another OCR, you may see how the application is working. So we get the raw video stream, and in real time, we're trying to detect, okay, in here, in this part of the video frame, there is a handwritten content. And then we can, for example, like add it as an additional layer and provide this kind of augmented reality experience that you just saw. And what is more important, why I'm talking about it, is that like more or less half a year ago, I've been here on WarsawJS, like giving the presentation regarding the optimization in JS, and most questions were related to not to the optimization, but to the application itself. So right now, I wanted to present you more about it, more about some various decisions that we made while creating the application itself. Okay, so what we are doing. So we are doing video and data processing, and we want to create for our users first this kind of screen. So like you already seen this. So I'm going to the next one. We want as well to archive the data that we detect and provide some additional features that could like enhance the experience of users, that they could do something with what we already detected. And at the same time, we are in here providing like the platform that when the, for example, teacher or I don't know, Scrum Master is providing like running some session with the whiteboard, people joining remotely or even like in the university sitting in the back rows could see exactly what is written on the whiteboard and could interact with it via the annotation, digital annotation, like in this example. So when thinking about why creating this application, the biggest, I would say, the part of it is like this content detection engine. And it's important that we are working with the high quality video stream. So we cannot like downsize the video stream, so make it smaller. And it's real-time scenario. So it's happening, as you can see, while you are working normally with the, for example, whiteboard. And there are two choices that you can have when thinking where to place, where to calculate all of this. On the server side or on the front end. On the server side, you can run large machine learning models. You have scalability. You can scale your solution as you want currently with public cloud providers. It's just easy, more or less easy. And you can use high-performing technologies. So that's great. If you want to do it on the front end, you need to know that your users can have like really poor laptops. Office laptops could usually not that great. They could be running side processes like multiple, I don't know, Chrome windows, watching, I don't know, some movies, digging Bitcoins, etc., etc. They can do a lot of stuff which will degrade, even if they have moderate setup, moderate desktop, it still could be affected. And mostly if you think about machine learning model, you will be forced to going into the native apps. But I'll say, server-side is not for us. Let's go with the front end. And question is, why? And mostly if you think about the processing of this kind of stream and you want to do it all the time, like we need to detect the new content, have like 1 second, max 2 seconds. So we need to, for 1 hour long session, like having 3,600 times, like try to detect this content. And if you want to do it on the server side, it's just like expensive. It's like really expensive. If for each session you want to do it, you'd pay a lot of money, and you'd need to charge your users for it, for the application. And for our application, probably they will not pay that much. So why not have it for free? And you can just run it into distributed architecture. So just run everything on the client side. And if I said that in the past, it was true that when you want to use machine learning algorithm, you want to have them, you probably better go with the native application. Right now, you can do it in the web app. You can just, for example, if you want to process like using classical computer vision algorithm, you can use WebAssembly. You have an access to the GPU via the WebGL or like WebGPU recently. And the hardware is what we observe with our startup. It's like having already a few years. It's really getting better and better. So even integrated graphic cards right now are behaving quite well and working quite well. And at the same time, for example, ARM architecture, great for machine learning. So if you have, like, for example, Mac, it will be running our stuff really fast. And additional pros, it's like we don't have any privacy issue. Like we have a little bit of them because we are processing this, what has been written on the table, but we don't have any privacy content related with sharing the images of people. What are they doing in the front of the camera? And this is like big thing, because if you want to sell something to the big company, they have like the policies for this kind of video sharing are like this. If you want only some written content, it will be like this. So it's much easier to go into these kind of companies and you don't need to protect this data as much. As at the same time, it's a little bit more greener than like using the public cloud providers, because if I'm going to AWS, they will need to purchase, for example, new node, new server to manufacture it. And in this case, we are reusing what already users have, so additional pros. So some tips and tricks regarding the video processing and regarding working with machine learning in JS, in general in web application. When you are using, for example, TensorFlow JS to execute the model, you may check, this is something that you may, I think it's good to remember about it, you may select the engine and you can run it on the CPU, so having JS or WebAssembly engine. Usually these are slower. JS usually is the slowest one. There are some few cases in which it is okay. Usually if you want to go with running the stuff on the CPU, go with WebAssembly. If you want to use GPU, usually it's faster, but then sometimes it can affect how your web application, the user interface will render itself. So then you may go with WebGL. Recently introduced WebGPU, providing more direct access to the GPU. But like when we are working with it, like more or less 1 year ago when it was like released publicly, then with the old hardware setup, it was performing better. And since we want to optimize for the poorest, I would say, hardware, it was not for us, but generally it may be case probably when look once again in the future to look into the web GPU. If you have computational heavy stuff, go with WebAssembly and use some component writing, for example, C++. You can run it in the web browser. You can use web workers if you have something that can be run, like some processing, video processing, data processing, can be run in background. just use it. Next, like almost the last thing, if you are thinking, for example, okay, I have machine learning solution, it's sometimes, I would say even often, it's good to combine it with the classical computer vision solution algorithm. So you can have, if you think, okay, I have I'm using machine learning, you're not stuck to it. You can add some classical computer vision algorithm. It will be fine. And short thing, because on the last presentation I was talking more about it. You can rewatch the video, which is still on YouTube, about our story when we are creating our own model. But generally, I would say why you should not do it, because you can waste a ton of your time and money. Results can be far from perfect. In generally, it's something that go with your own network. You need to have machine learning engineer to start, and it needs to provide you really strategic advantage. That it's something that there is nothing to the market that will suits your idea. You want to have it, then maybe build your own network. But if you are like working as a front-end developer, you don't need to reinvent the wheel. You can just, for example, use open source solution pre-built models, and then you don't need to train them. You don't need to get the training data. You just use them. In our case, for example, if we want to detect silhouette of the person who is like in the front of the board, we can just use body pics, which is just there running quite fastly, because it's like running in the low-res images. It's using low-res input. Or, for example, recently we are working on the new feature, like it's quite common on the market, like to provide audio transcription. And there is Whisper, which is really, the model is quite good. It's not, you don't need a lot of resources to run it, and you can just take the model and even deploy it yourself on, I don't know, AWS, if your scale is not that big. If it's big, probably having some VM with dedicated GPU will be better. One thing to remember, if you can do something in 5 minutes, probably others can do too. So if you're thinking about your new great product, probably the competition can just copy it and release same solution. So it's nice to remember it. And one thing that I want to mention in this topic, like you can even go further. And with it, like you can see that one of the things that we wanted to achieve is to go from this image, like the image video overlay, having this image, to go into the data format, which is you can modify. It's digitized, but it's editable as well. So we wanted how we can approach it, like use OCR, that's simple. But unfortunately, all the OCR systems are not working that good if you have this kind of data, which doesn't have nice structure. If you are working normally with the whiteboard, often you are mixing languages, you are adding some dashes, and for this OCR, it's like the results were far from perfect, I would say. So instead, like also, quite recently, OpenAI, like half a year ago, the OpenAI released vision-to-text API. And it's just great because in this case, we can just provide the image of the content to the model and receive some text representation, which is great for transcribe, but as well you can in here create via it some visualization using Mermaid, which is one of the format on how can you visualize diagrams. But something that you should remember, like it sounds great, but regarding the OpenAI, that you use only as a service, just put your credit card there and you are safe. But not exactly. And for example, what can happen is that you, using their model, you do a lot around it to provide the good results to your users' clients. Great. But the next day they are saying, okay, you are modifying our model or adding something new. And then it doesn't work that well. You need more token. There are some limit about how many tokens you can have, you can use. Even if you want to pay. I know one of the projects that they were having money. They were having the good business use case for their application, but could not go after some threshold because the Microsoft Azure said them, okay, you have a limit. And really there is a limit. And that after which you need to talk directly with Microsoft, and maybe they will give you more, maybe not. But for me, like there is also price tag. It's kind of costly. But the biggest issue that I notice with the OpenAI is the stability. Really, this is something. Thankfully, we are adding like the beta tag to the feature, because the amount of time this OpenAI is like down is really, really high. It's like I expect, okay, they're having so much money, probably their service will be great. It is not. From my experience, we have a health check connected to the services we are using, to the API, and it's really that like service is downgraded for a long period of time. So the question is, do I hate OpenAI? The answer is no, I rarely hate anything, to be honest. And in this case, still, even though they're having a lot of issues, we were able to build this kind of stuff, which is really like 1 year ago, it will be for us, wow, like having this kind of result will be just great. And we build it really, really quick. Like we right now doing a lot of post-processing, which is taking more time if we're adding the new, I would say, use cases for it. But in generally, it was like, whoa, that's cool. And without anything. Probably with one more thing about the previous stuff, probably in the future, we are thinking that if we'll get more users, probably we'll get some open source model like Llama and just run it on our side, because it will be mostly more stable. Okay, so right now a little bit about the architecture of the solution, because I told you about how we detect the content, but right now, sorry for the image, it was like originally it was good, but like conversion to Mac kind of killed it. But how to transfer the data that we have to our users, the video, the data. And we thought, okay, let's go with WebRTC and in parallel with the implementation Janos server. So we want to, via the video channel, to send the video with the content which is overlaid. And in the RTC data channel, we want to send the content only, which will not be like compressed with the loss, without any loss. So we want to provide it with the high quality, no matter if the connection, the bandwidth of the user is not that great. We are using like Janos, sending the data, and to be honest, it's like look great, but it's not. It's in our case, it was not working at all. And you may wonder why we failed. And there are like two reasons. One is like, none of them is technical. Like technically, we built it, it was running okay. We simulate like big session, it was, yeah, fine. But first, the costs. If we want to go with the, using the, for example, AWS, then we have managed service, which you can scale easily. You can, it's managed, so it's easier for you to maintain it, but it will cost you a lot. It's like we calculated the cost of running it, and it was way, way too high. There is an option, like for example, Zoom is doing it, Google with the Google Meets is doing it, Windows with the Teams is as well doing it, and you can make a business, but usually it's based on the long rental. You have the servers, I don't know, VMs, clean VMs, or like bare metal hardware that you rent for 2 years. And okay, in this case, the cost of the infrastructure will be much, much lower. And as well, you have the administrator on your end. So if you are a big company, it's easier for you to handle the big infrastructure on your side. But what is more important is that if we should even build a video conferencing application, like our business is detecting the content. And if I like give you application, okay, we detect this content. If you work with the whiteboard, do you want to use instead of your favorite video communicator, our communicator? Probably you'd say, maybe. But if you are going to the big company, no big company will tell you, okay, we are switching our license that all the users are like our employees are already used to, and we are moving to your new no-name solution. No one will do it. So what have we done? So the start is the same. So we are calculating a lot of it in the web application on the front end. And then we are sending compressed content via our backend, which is like we are having Redis as a cache, and as well to we are using a PubSub mechanism from Redis. Then we have standard relational database. We use S3 buckets to archive our data, to store it. As well, we are using in our backend Nest.js, which is like our application is deployed on ECS, which is like managed Kubernetes by AWS. And then what we are doing with the video, it's interesting. We are not sending it by ourselves, because why should we? We are just asking our users, okay, if you want to have this like video, the like content over video, use your favorite communicator. And for example, share the screen or use our application as a content camera, because we've taken our application, put it into the Electron, and then we are serving it as a way to build a virtual camera, which is detecting content and providing this kind of funny content, which is like over the video. And they're just using it as a standard camera on their desktop. And this way is cheap, it's lightweight, and our single node could like serve. Recently, we were testing like 200, 300 users at the same time. So it's really, we don't pay that much for our backend. And the last stuff that I have, it's what issue we have, what some of them we didn't manage to fix yet, delays and the data compression. So first thing, delays with the providing the content to the users. And the first one is like sometimes if the user have the poor video connection, poor bandwidth connection, poor internet, we are going with adaptive protocols, so not sending once per second this content, so it's like kind of live, but just providing it from time to time, so it's like with less frequency. So experience is slightly worse, but it's not that bad. The bigger problem that we have is with this content camera that I mentioned. That due to the fact that we are not only detecting the content, we are also creating this virtual camera that can be consumed by Windows, in this case OS. Then the users are running at the same time video conferencing application. It's taking really a lot of memory, CPU power. So this is something in which right now we are moving some of the component, the content detection component, into the native, I would say, side application, side process, which will be fully native. Because if you run something on WebAssembly, it's faster than JS. But if you run the native application and you want to run C++ code, like runs your machine learning model, it will be faster. It will be much easier to be done. And last stuff is about this content, sending high quality content over the internet. And this is interesting stuff because we first, like, you can see how the data is looking. So this is this part. And we just like compress it with the PNG, send the PNG over the internet. And it was quite okay, but still a little bit too much data for the users, especially with these poor internet connections. So we thought, okay, let's vectorize this content. So then if we put it into vectorized format, then it should be smaller. And the funny thing, it was not smaller. We then compress it, so it was slightly smaller, but finally we decided, okay, let's send only the raw data. We created our own compression algorithm because the data that we have is kind of special that you can see there are not so many, I would say, dark pixels. A lot of it is white. It's black or the two colors, or depending on, we have like 4 classes of colors, to be honest, that we can have. So you can compress it based on our use case. And right now we are doing it. And we still want to vectorize the content because it's providing the like nice curves to it. But we are doing it on the end user side. So yeah, I believe that's all. I believe that I managed to be in time. Yeah. So,
thank you. And yes, you were very, very precisely on time. Does anyone have any questions for Jerzy?
Hi, thank you very much for the nice presentation. I'm amazed about this. I have a question about the detection of the words, actually, or the text that is written. Because what I saw on the pictures that you showed us, it was mostly written in the capital letters or even small capital letters. How is it about like bad handwriting? Yeah, because people have it.
Yeah.
And also another question: does it support already languages, like different languages than English?
Yeah, so to be honest, like if you are using these new generative AIs, they are like scary good. Like even I'll just raise it to the ground because how good they work. Really, it's working great. That if you are being as a human being able to recognize what is written, probably it will detect, like recognize, transcribe it as well. And what's more, it can even take what the context and interpretation of what have been written. Because in fact, it's being able to turn the image into like more or less the text and then interpret text like the Open API. And then it have the power, for example, you have the image that I show you, there are some math classes that, to be honest, I don't know what is happening there. But if I go through, run our right now analysis model, the prompt needs to be quite specific about it, and it's still sometimes not providing the exact what you want on the first run. Sometimes you need to give it like 2 tries. But in general, results are great if you see it. For the commercial purposes, it's been rated like between 5 on 10, usually to 10 to 10. Sometimes providing like amazing like interpretation and visualization. Sometimes it's okay. You can see that, for example, some values are not exactly the same. That if you have the charts, because for example, it can interpret and digitize charts, and we can then visualize these charts. And for example, it could sometimes add additional bar if it's a bar chart. So it can make mistakes, but we provide like the interface which allow you to correct them on the fly. So kind of fixing it. What is important is that usually with like the models like large language models, you can use like fine-tuning or RAG to improve the quality of the results. And unfortunately, with the images, it's not possible. You cannot have like, I don't know, linked any database and improve the results. But even without it, it's really, really good. To be honest, going to 4.0 slightly degraded the service. This is what I mentioned about what they're changing in the model and forcing you to go with the models. But on the other hand, right now it's much cheaper. So some pros and cons.
I was wondering about 2 things. First, does it work with a blackboard instead of a whiteboard?
Like it could, and this is about the various languages. It could support various languages, but right now we are only Latin language we are supporting, because we don't support other ones because we don't have clients from other like the Chinese, Arabic. It's working, but we don't even look on it. With the blackboards, we could because to be honest, we have 2 algorithms like to detect the content. One is mostly based on the classical computer vision. The second one is based on the machine learning. The one with the classical, unfortunately, will never work. The second one, if we would have the customers who said, okay, I want to have it, we could train the model for the blackboards and have it, we even have the training data. But till now, there will be only few universities who ask about that. Maybe you will have it or not. Okay. But because of that, we didn't even care.
Hi. I have a question about this complexity you described. You showed us that things get messy, get hard to compute, but it's all on the presenter's side, right?
Yes.
Not on the receiver's side.
Yes, exactly. On the receiver right now, on the last slide was the vectorization. So we've taken the guys agree with it. So the already prepared vectorization algorithm, and we just run it on the client side because it's not that heavy. We can run it on mobile phones. We can run it on any desktop. So it's okay. And we just do it in sake of the data compression because we still perform the vectorization on the presenter side. But mostly all the stuff that we need to calculate is on the presenter side.
Okay, so it pretty much invalidates my other questions. Aren't you afraid of your property? If it's in the browser, it can be reverse engineered.
It is in the web browser. It
Yeah,
is in the
but
web
it
browser.
is on the presenter side, so probably it's your client. So
No, you can have a
terms
free
of agreement,
trial.
etc.
The answer is no. Yeah, like what you can do, like if you take our mimified code and try to re-engineer it, probably it will be easier for you to just build it from the scratch, I guess. So yeah, no.
No special treatment.
No. In fact, we are like right now patenting our solution. So rights for the patent, but mostly due to for the investor sakes. And yeah.
You mentioned performance problems with Electron app, probably because Electron has a whole browser in it. Why are you using Electron for your application? Why not something like React Native macOS or React Native Windows?
Because it was just easier and cheaper to just put there. Mostly, in fact, we are as well. We had to prepare. I didn't mention it. We have to prepare as well separate library, which is written in the native C++, which will like handle all the system calls from the Windows, because you cannot get an access to the to the system interfaces, and we need to have system interfaces because we need to provide it as a virtual camera. So mostly due to the speed of the implementation and to just lift and shift it. And right now, even if we use any, like we have to be honest, to be able to run it quickly, to run bigger models, we just have to have them as a native code written like native application. We just have DirectX written in C++ or like C or whatever.
I think you can still do that from React Native, macOS, and Windows. I already reached out to you on LinkedIn, so accept me and we can talk later about this.
Okay, great.
Maybe
sure.
we can help out.
Folks, thank you very much. Please give one big hand, another hand for Jerzy Nowiński.
Warsaw.